Find the domain of g of x equals the square root of 9 minus x squared. When finding the domain of a function, there are 3 rules to think about. 1, we cannot divide by 0. 2, if we are doing an even root of something, then that thing has to be greater than or equal to 0. And finally, if you're doing a logarithm of something, then that thing has to be greater than 0. So we are looking for any of those 3 things to happen. There's only one of those happening here in this function, and that is that we are doing an even root. We have the square root of 9 minus x squared. So the thing that we're doing the square root of, 9 minus x squared, has to be greater than or equal to 0. And now we just need to solve for x. So this says that 9 is greater than or equal to x squared. Now this is a very dangerous thing to go from here, because not all operations are not all operations preserve the inequality, and the square root operation is one of those, meaning I can't just do the square root of both sides and be done. This is going to take just some thinking, okay? We need x squared to be less than or equal to 9, okay? Obviously, x squared is equal to 9 when x is either 3 or negative 3. And if we want x squared to be less than 9, that means x is going to be between negative 3 and 3, right? I can't be bigger than 3. I can't be less than negative 3. And so this means that x has to be between negative 3 and 3. And so for our domain then, this is our in an inequality form. We could also write it in interval notation. I'm going to write in interval notation here. We're going from negative 3, and we can equal negative 3, so we put a bracket there to indicate that x can equal negative 3. And then we go all the way up until 3. And again, we can equal 3, so we put a square bracket there as well. This is our interval notation for the domain. You can also do the set builder notation, which is that we have the set of all x values that are real, such that, and then that inequality that we wrote, negative 3 is less than or equal to x, which is less than or equal to 3. And either one of these would be an accurate representation of the domain.